Hi everyone. Hope everyone's doing well. Welcome to another episode of Graph Builders Office Hours. We've got a big one today. We've got the founder of the Graph, Yaniv Tal, here today. How are you doing, Yaniv? Welcome to Graph Builders Office Hours this Thursday, December 5th.
Hey Marcus, good to be with y'all.
People are filtering the chat right now, and we'll just wait a few minutes here. Where are you calling in from?
I'm in New York today.
Okay, very cool, very cool. Yeah, New York is, I would imagine, cold right now. I would imagine pretty dang cold.
Yeah, I think we got maybe the first snow yesterday.
Okay, cool, cool. Yeah, it's been a minute since I've seen snow. I'm out in Atlanta, so we did get snow. I think for, if you want to count it, snow for like a second or two on the ground as it just hits and then evaporates. So we got people coming in today in the chat. How's it going, Thomas? How's it going, Lewis? The Graph Germany. How's it going, buddy? All right, everyone. With everyone coming into the chat, with everyone hopping in, I just want to say quick announcement as always, as we are always building more subgraphs, more substreams. I want people out there to understand that Builders DAO is out there. If you want to have a subgraph or a substream powered subgraph to be built to your specs, they're out there. Go to buildersdao.tech. There are professionals waiting to be hired, and they are really good. Go to buildersdao.tech and get your front end powered by the graph. That'd be awesome. With that being said, Yaniv, I hear there's a new spec in town. I've heard it's called GRC-20. Is that the case?
That's the one.
That's the one. For right now, chat, if you're in chat, go ahead and drop questions if you have them. I'm going to step off stage and let Yaniv take over and speak on this new spec. So take it away, Yaniv.
Awesome. Thanks a lot, Marcus. Cool. So yeah, happy and excited to walk through all the new developments happening on the graph related to knowledge graphs. So as many of you probably heard, we just released this new spec, GRC-20, defining a new knowledge graph standard. And I want to walk a little bit today through some knowledge graph basics, why knowledge graphs are important, and actually walk through the spec and talk a little bit about kind of what's coming up for developers on the graph and what this means for people who are building on the graph, who want to build amazing Web3 applications, and the Web3 community as a whole. So let me start by sharing. In June of this year, we published a blog post called "Knowledge Graphs Are Web3." You might have seen this, and kind of walked through, why are knowledge graphs important and where are we at even in the Web3 journey. I think in the last cycle, Web3 became a really big buzzword. People got excited about it. We saw things like NFTs. But the reality is, most of us aren't using a lot of Web3 applications every day. Most people outside of the crypto space, definitely are not using Web3 applications every day. And these applications, the ones that do exist, they're not really all composable with each other. And for me, that's always been kind of the main benefit and point of Web3 is this kind of composability and interoperability, right? And yes, verifiability and openness are big parts of what allows you to get there and to have like an open, amazing web where everything kind of works together. So I talk through this in the post. If you haven't seen it, this is a nice kind of like background, and I even gave some kind of examples and kind of described basically why knowledge graphs. And one of the ways that you can just kind of understand this a little bit is that like even the applications that people are building today in Web3 end up being fairly siloed, right? It still ends up being like these applications. Now, every once in a while, you get something that's maybe a little bit more of almost like a platform or something, right? Like a Farcaster. But even Farcaster, right, where you have things like posts and whatever, so they define a type like posts, and then yes, you can have lots of different apps that are built on top of that, but it's really with like a fixed set of these types that they kind of define. But the world isn't siloed into like, okay, here's the social bucket and here's this bucket and here, everything is actually interconnected. And so, you actually need a way to define composable, types and and schemas and things so that, data isn't living in these silos. And you can have an application that is maybe, consuming data from like 20 different places and then producing data that's relevant to, 10 different things, and it all just works, right? So and that was really a core idea behind the graph, right? Is that it's all just one big global giant graph, and developers and individuals should be able to access like the whole graph, and you should be able to contribute to different parts of the graph. And so knowledge graphs are really the technology that kind of make that possible. So if we look at GRC-20 and knowledge graphs, I'm going to start with like a few slides, just a little more visual, and then I'll pop into the spec itself, kind of walk through the spec a little bit, and want to just kind of kickstart people's understanding, maybe get you there a little bit faster. Two of the main kind of concepts in GRC-20 are entities and relations, right? So everything can be modeled as an entity. So a person can be an entity, a project, a city, right? An idea, right? Something like art. And that's an interesting thing. If you have like the concept of art, if you want to reference art, right? If you want to say, okay, this is a piece of art, how do you describe that? And how do you do it in a way that other people can also know that you're talking about art, right? You don't want to use the word art because that's even the word art could mean different things in different contexts. And so with entities, everything has a globally unique ID. And then people can reference it. They can reference it across lots of different applications. If you're talking about the same thing, then you want to reference it by the same ID. And then things are related to each other, and that's using relations. So relations would be like these arrows, right? So for example, say you have a course on content marketing, right? Maybe this is like an educational app or something, and the course has many lessons, right? So maybe you have a lesson on storytelling, you have a lesson on marketing funnels. So here the relation is that like each of these is a course lesson, for example, could be a name of a relation, and then you're pointing to a lesson entity, right? And then the lesson entity can have a bunch of fields, can have a bunch of data, right, that's related to the lesson, and you know that this lesson is related to the course because the course has many of these lessons. Similarly, maybe the course is about a bunch of topics, so you can point to those topics. So you form a graph by basically having entities and relations between those entities. Now, the data itself, to structure the data with GRC-20, the core like atomic unit of data is a triple. Right? And this is how knowledge graphs, like semantic web knowledge graphs, are typically defined. Sometimes they use different names for these, but we like entity, attribute, and value. And so the entity, this is what the IDs look like. So you have a global unique ID that references the entity. So maybe we have a global unique ID for Albert Einstein, right? Anytime anyone wants to talk about Albert Einstein, like this is the ID, for example. And then there's an attribute. And so what we want to do is define like a single data point here, right? So here we have an attribute called birthday. And here, birthday might be an attribute that's relevant to a person like Albert Einstein. But birthday could also be an entity that is relevant to something like a pet, right? Maybe an animal also has a birthday. And interestingly, because the attributes have globally unique IDs, a birthday for a pet is actually kind of the same thing as a birthday for a person. And so you could use the same attribute ID to talk about the birthday of a pet, and if you want to know everybody in the household's birthdays, including the pets, you can do that query, right? So this is the kind of thing that when you have rigid schemas, which, most applications today, they have these kind of relational rigid schemas. You don't have these uniquely identifiable like attributes and that can apply to many types, and it's really, for each type, it's kind of its own thing. And so this is a much more flexible way of specifying what you want to describe when you're adding data. And it's also powerful because, for example, maybe in the future we decide, hey, we don't like the name birthday. We could change this. We could call it, birth time or whatever we want to do, and it'll just update everywhere, right? Because everybody was referencing this attribute by ID, right? So you don't have this thing where, like, in your code, it breaks everybody's code. You change the name of something, right? So that's another nice little benefit. So there are really a bunch of benefits with having kind of triples being the native, the core atomic unit, and then you have the value, right? And so the value can be, in this case, this is like a time here. It could be rendered different ways, but this represents like a single data point. And so, when you have triples as the atomic unit, one of the things you can do is, you could publish a set of triples, right? Here's a bunch of data that I want to publish. And those triples could be referencing any entity anywhere, right? They could be referencing any attribute, and then you have any values. And so that is incredibly powerful to be able to, publish data about anything. And because the entity ID, attribute ID, right, these are globally unique, and then these values are self-describing. I'm not going to go into too much detail about this exact format of the value, but it's fully self-describing. So anyone can always interpret, the data that you're passing them. And so what that means is anytime you publish knowledge, right, you can publish knowledge about anything. It's something that anyone that conforms, that speaks GRC-20 can interpret that knowledge and can use it in their applications, no matter what their application is about, right? They can always kind of get the information about the entity, the attribute, and they can always accept your triples, and they can include them. And so it's really a level of interoperability that we've never really seen before on the web. And it's taken many people, I think, a while to understand why this is so powerful, but hopefully this helps create a little bit of intuition to understand why this kind of a format is truly the most interoperable way of publishing and consuming knowledge and information, and especially when you're operating across organizational boundaries. So this is just a list here of kind of the native types. Actually, entity is not a native type, so I need to remove that from here. We're using something else. But the rest of these are correct. Actually, I want to talk about types next. So I was saying, when you want to work across organizational boundaries, right? Because one of the things that happens, and Web3 has not been immune from this, is when you're building applications, usually what you do is you kind of define a schema for your app, right? So maybe I want to build a job board where people can find jobs. And so I say, okay, there's roles, there's job openings, there's maybe skills, there's, the cities where maybe a company's in a city and I want to look for a job in a certain city or something like that. So you kind of define your schema. And usually when you do that, right, it's kind of specific to the application. And what you don't do is you don't really it's really hard to get different apps to agree on shared types, right? So probably if I'm using a city, right, so that I can find a job in a city, maybe my definition of what a city is kind of only applies to my app. And then, there's probably millions or billions of, millions of other apps out there that also talk about cities, but they have their versions of cities. And it's not really clear, if someone adds information about a city in one app, it's not like my app's going to automatically update or even has that option, or like somebody has to come in and write code to try to integrate everything to everything else. And that's why we don't have interoperability, right? And another thing that makes this all really difficult is is when things change, because you never know the structure of everything up front. Right? You learn more, something that wasn't important before suddenly becomes important, so you want to add it. And if you have all of this data that's been created and you're evolving the schema, right, there's a very high chance that the data that you had no longer conforms to the schema as it changes. And so you have all of this invalid data, right, that you can't, that breaks validation. And so there's a bunch of issues that you have kind of with strict type systems. But the other side of that also isn't great. There was a big movement for like NoSQL databases, right, where there's like no schema, it's schemaless. And you end up with a whole other set of issues when you have like full schemaless as well. And so what we do is it's a really tasteful trade-off where we have types, and types can have a set of properties. And this actually includes both the native like attributes as well as relations, which I skipped over relations. I can come back to it. But essentially, a type has a set of properties, and these properties are kind of hints, right? They're providing some structure. So a place may have an address, it may have hours, it may have like a phone field. But it's not like a strict validation, right? So it makes it so that if I'm looking for places, my tooling can tell me, hey, you might want to use the address, you might want to use hours. Here are things that are probably exist, right, on these places. So that makes it really nice and convenient. But it's not going to break, if the data doesn't conform to this. And the other thing I can do is my entities can have many types. And that's also very powerful, right? So Golden Gate Park, right? It's a place and it's a park, right? It's both of those things. So an entity can have many types, and then what you'll see is like the union. You'll see the addition of all of the properties across all of those types, and okay, these things might have this kind of structure. And so types are a really powerful and flexible way of adding structure to information, but in a way that doesn't break the composability and that keeps everything interoperating. So really powerful. And then finally we have relations. And relations is, I guess I already mentioned them, but the thing that's really powerful about the way that we handle relations is that we support what's called a property graph model. So if you have entities, so you have an entity for James and you have an entity for Anita, you could add a relation that says, hey, James's spouse is Anita, right? They're married. And then what you can do is, so you have essentially, we internally, we actually model relations as entities themselves. So the fact that James, his spouse is Anita, is itself an entity, which means it can have its own properties. So you can say, okay, when did they get married, right? Their married date was 4th of October, 2024. Right? Maybe there's actually an entity for the wedding, right? Maybe they have like a wedding website and you can see photos of the wedding or whatever information where it was. So the wedding of James and Anita can be its own entity, and then you can add a relation, right, from this relation to the wedding, right? Because it's just another property. And so this ends up being really powerful when you can describe things about whether or not things are related or how they're related. It's a really, really powerful thing. And so with this, we can build like a rich graph where we can connect anything to anything, right? These relations, they have a flexible way of, you can define kind of these like hints about what types of things you might want to relate to, but really you can relate from anything to anything, right, to any types of entities. And so it's really the most flexible way of describing these really powerful graphs. And we designed this spec really from the ground up. The previous standard for knowledge graphs is a spec called RDF. And there are many problems that we think RDF has. It's been out there for 20 plus years, and it hasn't really taken off. And I think, that already speaks, for itself. it's an XML-based standard. I can't think of really a standard in the last 20 years that was XML-based that really took off. There's a lot of just incidental complexity in the spec. If you look at it, if you have to write your own implementation of the spec, there's quite a few things about it that are pretty convoluted. It doesn't support the property graph model that I just talked about, so that's quite limiting, and it actually really limits what you can do.
Real
And
quick, Yaniv, could you make the text a little bit bigger? That would be awesome.
yeah,
Yeah,
I
thank
don't
you.
know how to hide this guy. Is it this? Ah, great.
There you go.
Um, so the other thing is the way they handle IDs. The IDs are resource locators that are typically pointing to these like servers. So that's kind of the model, is you kind of have servers, and then you tell people, oh, you want to get the information for this entity, talk to this server. And yeah, you can use DIDs, you can use content address URIs, but most of the RDF data out there is pointing to centralized servers. So anyways, we need to get people to migrate away from these like centralized locators, right, to something where it is decentralized, the data is self-describing. You don't have to go talk to a server, a specific server to get the data. So for all of these reasons, we designed a new spec called GRC-20. And it's a really elegant, in a sense simple, but we added just as much complexity as you need to really describe these graphs. And so we go through the encoding, right? We use protobufs from Google. We did benchmarking against a bunch of different serialization tools, and this is the one we chose. This is how we handle IDs. So they're kind of base 58 encoded. We basically start with UUID 4. We don't lose any entropy, but we condense the size, and we make it so it's easy to kind of copy and paste, and it works well for humans. So that's nice. I haven't really talked about spaces. There's going to be a lot of interesting things coming out soon related to different types of spaces. But right now, we're just talking about serialization. So you just think of it as the logical group, where essentially you're like publishing triples to a space, and each space kind of has its own knowledge graph. So that's the way to think about it for now. Describe kind of these triples. This is kind of what the value looks like. So this is where I was saying that the values are self-describing, because basically you can actually describe the type of the thing, so you always know what type of thing you're looking at. You can have some additional options, things like formatting, units, and language. So that's all part of the value, right? So here you can see a triple, right? The entity attribute value could look like that. And then there's the native value types. Right, so these are the native ones, text, number, checkbox, URL, time, point. They're going to find like this. We give some examples, formatting, all this kind of stuff. And then we describe types. And so basically the triples, just with this, you can start to publish and share data. And then basically, the way the GRC-20 works, right, it's these very basic building blocks, and then things build very elegantly into more and more complicated structures, right? So types in GRC-20, they're actually entities just like any other entity, right? So there is a type entity, and there's did we describe attributes yet? Well, here we describe attributes. So we already kind of know what an attribute is, and so here we define basically the type entity, right? And so there's an attribute called type. Well, type is, so it's actually a relation, but a type has attributes, and it can also have relation types. And now I am just thinking for a second why types would actually have. Oh, right, because these are the properties. These are the properties on the types. So this is one thing that that I was describing before is, and we just say it somewhere, that the attributes, the way the nomenclature work is, we kind of use attributes when we're talking about like the native types, so the triples, and then relation types when we're talking about relations. So, and together, both of the all the attributes and all the relation types are we can just call them properties. So in the apps that use this stuff, basically, the entities have properties, and that's kind of the way to talk about them. And then we can kind of dive into the attributes. So attributes are also themselves entities, right? So if you have like the attribute for birthday, that's an entity. You have an attribute for, price, that's an entity. And then you can have a bunch of fields describing that attribute. So these are those attributes. Then we describe kind of relations. So a relation, right, we also model it as an entity, and a relation has a from entity and a to entity, right? So it's directed. And then a relation also has an index. So if you have multiple relations, they can be ordered against each other. Right, so this is similar to, if you've used something like Notion or anything where you're adding like tags, for example, right? So you're like looking something up and you add it and maybe it shows up as a pill. You look something else up, you add it, it shows up as a pill, right? Kind of like these. So these, right, here you have a bunch of relations and they're ordered. So you can reorder them. And that's what the index is for. For the indexing, we use fractional indexing, which is a pretty cool thing, which allows different people who are updating things at the same time to kind of modify the orders of things, minimizing a chance of conflicts, so that you can kind of reorder things independently and always end up with a clear order at the end of that. So those are the relations. A relation can only have one relation type. So everything else, you can have multiple types, but a relation can have 0 or 1 relation types, right? So you say, this person's, friend is this person. And if you want to have another relation from the same people, so maybe they're friends and they're also coworkers, right? So the coworker would be just like a second relation, right? So each one of them gets its own relation to say, okay, they're friends and they're coworkers. And it's ordered. So if it's bidirectional, then you also put maybe a relation going the other way to say, well, that guy is also friends with that guy, and that guy is also coworkers with that guy. So each relation is unidirectional, right? It's got the from and the to. And that's how you define relations. Every entity has some implicit entity properties, and those are name, types, description, cover, and block. So cover is like a cover image that you use in any application. It's nice to have illustration. It's not the 90s anymore. So having kind of a cover image for every entity really in the system is a nice thing to standardize on. Right, to have a description, which is maybe 2-3 sentence little short description of what a thing is. The types, right? The name. So name, it's really a standard attribute. We want basically every entity to really have a name. You don't want to look at things by IDs. And also, it's silly to sometimes, call it a title, sometimes call it a something else, right? To have different attributes that are really referring to like every entity. You want to look it up, you want to search for it, you want to, see it. So it's called a name is the attribute, and that's now standardized. Types, description, cover, and blocks. And we don't talk too much about blocks here. We're going to be publishing a content spec that describes a little bit more how to have rich content and pages for different entities, but that's left for a future spec. And then we have system properties that are created by the indexer, right, that are coming from the on-chain data. So when you publish edits, they can get indexed, and then the indexer can add kind of a created at, updated at, created by, and versions. This is essentially coming from the blockchain transaction. If you're publishing this to the global graph, it goes to a, you submit a transaction on chain, and then we can have consensus over the state of the graph, which is pretty great and something that they couldn't do before we had blockchains. And then a little more about spaces. So, and then we describe a little bit about kind of the ops, so how you set the triples, you delete the triples. It's basically a log of ops. The edits. So this is especially relevant for basically the on-chain part for public spaces where you want to publish on-chain. So you have global ordering on the ops. You publish these edits. You can see who the authors are. There's version, so an edit looks like that. And that's basically the spec, right? You can add edits, and then the spaces, there's a few things with spaces there. So that's an overview of the spec. So I just walked you through it. Hopefully that helps a lot. And where are we at? We want people to review the spec. We want people to provide feedback, because once we freeze this thing, it is frozen, right? Any amount of knowledge that's created using the spec, like, we're going to need to support it forever. So this is why we announce and we release just the spec, and it's a very short comment period. So we want everybody to review the stuff now because we have a lot of exciting things that we want to release. We want to get people using this stuff, but everything depends on the serialization format, because this is the thing that can't really change. And so once we freeze this spec, then we could start generating knowledge, and we can start creating some public spaces. We can define some core types that lots of different applications might want to use those types, and we can start building a bunch of amazing things. So we have a forum post. Marcus can share a link to the forum post. And this is where we would love your questions. We would love your feedback. Now's the chance to provide any feedback. And then what's going to come next? What does this mean? If you're a developer and you're interested in knowledge graphs, at this stage, get familiar with the concepts. Right, get familiar with the spec, and then early next year, we're going to be releasing a framework and a set of tools that make it really easy to use GRC-20 in your own apps. So the tooling is going to be really great. It's going to be really easy to build apps with this stuff, and they're going to be incredible because they're really going to be composable. Right, we're really going to realize the vision of Web3, and so whatever it is that you're building. You probably want to, be building part of this open, verifiable, composable web, and once we get just even a few of these applications working together in this just seamless way, it's going to create such a great experience that people are going to love using your apps, and they're not going to be able to go back. And so we want to empower you to build the apps of the future, on Web3. And so let's work together on this. Please, I'm going to be around now to kind of answer questions, and I'll be around afterwards. And please jump in the forum, be part of this discussion, and let's get these knowledge graphs out into the world. All right.
All right. Did great there. Thank you so much, Yaniv, for going through that step by step. We've got some questions here from chat. I'm just going to go through them one by one. Polly B asks, what would be some examples of end users you would expect that would benefit from this?
Yeah, so I guess there's two sets of users, and I think I know which one by that description, but we kind of have the developer users, and then we have kind of end users. And the end users, they'll be using many of the applications that the developers build, but maybe they'll be using things themselves. And so how do I expect that knowledge graphs will kind of impact end users? So many ways. So I described that there were a few different types of spaces, right? Personal spaces and public spaces. So let's look at something like a personal space. So each individual should have a personal space that they control, right? So, right now, so for me, right, I'll have my personal space. Now, if somebody wants to look something up on Yaniv Tal, right, who is Yaniv? Where would they go? Maybe you go to Google, right? You type in Google, you're like, okay, Yaniv Tal. What information comes up? I don't know. Whatever Google, the company, decides comes up, right? And they might have information about me. It might be right, it might be wrong. Each app is going to have a different view. If I go to LinkedIn, it's going to have a different set of information about me. If I go somewhere else, it's going to have a different set of information about me, right? And so you actually get to this really interesting, societal type questions once you start really looking at the structure of the knowledge graphs, the knowledge and information, and how do we agree on things generally, right? So in this case, there should be a public space where I can publish precise information about myself. This is the company that I work at, and that's precise. And these are my roles. This is what I like to do, and this is where I live. And this is any information that I want to make public, I can publish it to my personal space. I can show my portfolio. I can show whatever it is, and right. So it's like a website, but it's better because it's on chain, and it's the raw knowledge, right? It's not just a page, right? It's not an HTML page. It's here's all of the knowledge about me that I want to publish, and then people can use it in all kinds of different applications. So that's my personal space. But then you also have public spaces, right? So just because I could say, Yaniv is the best engineer that ever lived. Is that true? I don't know. So maybe that's a question that goes to the software space, right? If I'm making a claim that I'm the best software engineer that ever lived, the software industry may disagree with that. Maybe, I could think of 100 probably better engineers. The software industry is well, Rich Hickey's up here, and this guy's up here. So,
and that gets into the idea of the governance of this, which you mentioned a little bit as well.
That's right. So the governance is going to be another really interesting piece, and it's going to be actually the next thing that we talk about. And so we're kind of sequencing this out. We're starting with the serialization, and then we get to these really interesting questions of things like governance, and that's what we're going to get to next.
Very cool. Looking forward to that. The next question is a little bit more technical. This is coming from CryptoViso. Can a triple have a value that is a collection of other triples, or is that going to be too much parenting and grandparenting?
Yeah, so collections or arrays are not one of the native value types you may have seen, and so that is not supported, and so the way that you handle that is just by relations. So if you want to, there's many-to-many relations, right? So maybe a company has many team members, right, or employees, whatever you want to call them. So that's a many relationship, but you would just, each one of those would be its own relation, right? They're ordered, and that's how you handle having multiple things.
Cool. Got another question.
You find an entity, which is kind of similar, but an entity having multiple different fields, and then you just point to a relation to that entity, which could have all of the data on it.
Okay, cool. Got another question here from Louis Bell. I'm going to mess up that last name, Bellier. That might be correct. From Penex. General type question. I see a lot of schema work. Is there a goal to follow common schema structures and take some from Web 2 and add some Web 3 ones to do GRC-20? If yes, any specific ones?
So when you're talking about schema structures, are you referring to the way that we define schemas, or are you referring to specific ontologies or types or things that might exist?
He's in chat responding right now, so I'll get back to you. Defining types, yes.
Okay, so that's really in user land, right? So if there are standardized types for things, right? Here's what a place looks like. I know there's or a restaurant or something like that, because there's places that already use that. We could use the same structures, but it's up to kind of the people who are organizing the ontologies to use the existing standards or to create things. So we're creating flexible tools. Each team can kind of define their own schemas however they want. There's going to be shared spaces to encourage collaboration. If the people who are, governing those shared spaces want to use existing standards for things, they can. If they want to change them, they can. In general, we've designed this system so that it's easy to modify and evolve and change things over time in a way that doesn't break, existing applications.
He reacted with the fire emoji, so I think he answered that very well. And this is a follow-up question from Louis. We have, how do you think it will process updates on a fixed blockchain schema? Updated date and time are something very important in Web 2 for search engines. Curious of your thoughts for GRC-20.
So the question is, I guess that like on chain, the things are more fixed.
From what I understand, yes, he's clarifying right now. Updated time and day, for example, yes.
Yeah, well, for sure. I mean, the blockchain is kind of, the source of truth for a lot of things. And okay, so for this version right now of GRC-20 and what we have here, basically the only thing we're taking from the chain is the published knowledge. But we also, excuse me, have built a decentralized network of indexers that can index all kind of blockchain data. And we do want to merge these two things. And so we don't have anything to announce on that yet, but the way you could start thinking about it is that if you have something like a subgraph or like a substream or something like that that's indexing blockchain data, that component should be able to produce entities in the knowledge graph, right, and update triples and stuff in the knowledge graph. And so you can have like a pipeline, right, that you're indexing and ingesting, there's all of these on-chain apps, and all of that's updating things in the knowledge graph, but you kind of have, right, the knowledge graph is this thing that is, larger and all interconnected and, with the schema, and it's almost, you think of it as kind of the up-to-date representation of everything. But maybe, the data can come from different sources. So you could imagine then the knowledge graph being a combination of knowledge that is published directly as knowledge and also knowledge that is created in response to actions and events and things that are happening like on-chain.
All right, very cool. You brought up the graph, and I'm sure people here are wondering about how the graph as it stands today will interface with GRC-20. So whenever that does, more information comes out about that, I'm personally quite excited to see where that vision lands. And with also where things interconnect, there's another question on how AI search engines index from LLMs in a similar fashion. Any thoughts on how AI search engines, SGEs, index from LLMs and possible ways to be SGE friendly? Personal motivation and side quest of a developer out there. So.
Yeah, totally. So knowledge graphs are actually incredibly powerful for AI. And one of the biggest issues with AI, right? I mean, it's all about the data and what it's trained on, and also like what it answers questions using, right? So you almost think of AI as more like a user interface, than anything else, right? It's like I want to, give a question and get back an answer. So it's kind of like the UI. But then behind that, okay, yes, you have a trained model, but the model was maybe trained a few months or whatever ago. It's not trained on up-to-date data. So if you want to ask questions and you want to get relevant responses that are correct, somehow like the LLM needs to actually like ask a data source, right? It translates and it asks a data source, it gets back an answer, and then it composes a response to the user, right, in natural language. And so the question is like, what source does the LLM use to actually try to answer the question? And if you have an up-to-date knowledge graph, it's actually the best possible data source for these LLMs because it's very precise in its structure. So the LLM can ask like very specific questions. It can get very specific answers back, right? And once it knows how to kind of speak knowledge graph, then then it can basically answer any question it has and get correct results. And so what that does is it removes hallucinations, right? It gets rid of hallucinations, and you can always point back to, here's where I got my answer from, was these entities, and this is, right? And the other thing is it decentralizes the knowledge. And that, to me, right, is actually the most important application of AI and Web3, right, is that we don't want these large centralized companies to control the truth, right? We don't want like OpenAI determining what answers people get when they ask different questions. And so if we have a public process, we have a decentralized knowledge graph, right, that and we'll get into some of the key things with governance and that kind of stuff, as I mentioned, pretty soon. Now you have a decentralized way of organizing the knowledge that the AI uses, and so it's much more, democratic and meritocratic and resistant to capture and censorship, and I think that's going to be really powerful.
Yeah, the point you bring up about the linking of the different data all the way down and all the way through in an accurate way, you're able to have that citation essentially from absolute genesis of the data all the way to where the AI is presenting the data, which right now we don't have, and that is really really cool. I like that idea.
Right, and then
Uh,
and then if you ask yourself, if you ask an AI a question and it gives you the wrong answer, like what recourse do you have? Like if you know that's wrong, can you just go in and fix it? Like no, right? And so that's the thing that we're going to be able to do with the graph. That's really powerful, right? It's like, oh, we're actually giving the humans, power and control back to, like, you're not stuck with this bureaucracy, right? Where it's like we can't change it. No, it really is power to the people. There's always a way you can go in and you can fix whatever's broken out there.
that's really cool. That's really really cool. Let's see. I have a question here. Uh, let's see. Geo and GRC-20 and the graph. You've been working on these projects, and I'm curious how, in your mind, they complement each other years from now. Like, I know we don't necessarily have specifics, and we'll get into that, maybe in the next few months of how they're all going to interact. But I want to kind of go a little bit higher level of the vision you're seeing for this GRC-20, the graph, and also Geo, if there's anything that you want to comment on
Yeah.
with that.
Yeah, so what I would say is I think a lot of this is kind of in flux. And so, I will share with you, my opinion. And obviously with the graph, there's a public governance process and everything else. It's a decentralized protocol. I'm one man. But I'll tell you my view on it is all of this, right, is always been my vision for the graph from day one, right? It's called the graph. So to me, the graph is the global graph of all of the world's public knowledge and information organized and served in a decentralized way. That's always, to me, from day one, what I wanted the graph to be, this global graph of knowledge and information, right? But it's decentralized. And so there's two parts to the decentralization. There's decentralizing how it's organized, and then there's decentralizing how it's served. Right? And so in a sense, right, it's like today, a lot of what we've built very successfully has been this like indexer network and this way of indexing kind of blockchain data. And to me, that's kind of the first half of the puzzle, right, is this decentralized infrastructure and indexing. But it doesn't really get to the organization. And to me, the organization is really key because at the end of the day, like if the data isn't on there, then how much are you doing? And so like ideally, there's a point where like anything that you want to know, the answer's on the graph, right? And the knowledge, it's all organized on the graph in a decentralized way. And that was the idea behind the curator role. Right, so from day one, we launched the network, December 2020, and there was a role for the curator. And a curator was supposed to be, right, like anyone who wants to organize knowledge and information on the graph, because it was very, it was clear that that needed to be a role, that people need to organize knowledge and information for it to kind of be on there. And some of the knowledge and information is just going to come from applications, just as people build, use apps. So developers will build all these apps, and so some of it will come that way. But but it is there's a larger network here, and there's ways that things kind of need to interoperate. And so to have a role of people who can go in and make sure everything's stitched together properly and all that kind of stuff, just organizing knowledge, that was always clearly important. And that role was not successful in the way that it was built. Right? Neither the economics That the economics didn't make sense, and then we didn't give those curators the tools to actually do that, and so so that never happened. And so to me, that's just the graph. When we're done with it, it should be the global graph, right? It should have all the world's knowledge and information, and it should be available on this decentralized network of indexers, so it's always available to everyone. GRC-20 is just kind of the standard for knowledge, so lots of apps can produce knowledge that conforms to the standard, and then anyone who wants to build tooling or infrastructure or applications that can understand the knowledge, right, they're all speaking the same language. So it's that type of like a standard. And then ideally in the future, Geo just becomes a browser. We're not at the full browser vision yet, but essentially what we're doing is we're building the user interface for browsing the whole graph and contributing knowledge to the graph. And we think, there will be millions of custom applications. People won't need to use our browser the same way that you could use a web browser today, or you could use, the Facebook app or whatever, right? So it's open and people can build lots of different applications, but we think there's value in having at least one app that lets you browse the entire graph and contribute to any part of the graph. And so, we're trying to build the best interface for that.
Awesome. Great answer. I want to bring it all the way back down to the spec. That was a huge high level one. And let's go all the way back down to the spec and the kind of the call to action that you are asking developers listening in on to give critique, give feedback on the spec. Are there any specific sections on the spec that you are most curious about feedback? Is it the entirety
Yeah,
of it, or are there certain parts that you're like, hey, devs, take a look at this, please?
great
That's what you're
question.
interested in. Yeah.
Yeah, great question. So there's a few. One is how we represent IDs. If
Mhm.
anybody can find any flaws or reasons why it's not a good solution, let me know. I
Mhm.
shared a little bit of the motivation there, but essentially, like, it could technically be more efficient
Mhm.
if it was bytes instead of essentially like strings, right?
Mhm.
It could be more efficient, right? Because we started with the UUID 4, we stripped out the dashes, so that was 32 bytes, and if you actually, byte encoded it, you could get it down to 16 bytes, but it wouldn't be kind of human readable. It wouldn't be kind of alphanumeric. And
Mhm.
so we thought it was a good trade-off. You end up with 22 bytes. So I don't know, for the database people out there, that's a question, is the efficiency versus usability. So that's
Mhm.
an interesting question. We're not using DIDs. There's reasons for that, but anyways, we could have conversations about IDs.
Mhm.
Have conversations about the native types. Did we pick the right native types? Is there anything that's missing in your application? You can't represent the data that you need to with the native
Mhm.
types. I will say we left it out of the spec for now, but I'm very interested in adding Parquet as something that is basically an action that you could like import, basically almost like bulk import data from like a Parquet file. And
Mhm.
there's interesting questions about that because the current spec, it doesn't basically address like time series data. And I do think time
Mhm.
series data is probably best handled with something like a Parquet. So I don't know if it needs to be part of the spec or if it's part of a future spec, but that's an open area of discussion. Another one is validation. So Denver just left a post, I think this morning in the forum, about slightly stricter validation rules when it comes to, for example, changing an attribute's value type,
Mhm.
to restrict that.
Mhm.
And the interesting trade-offs that we need to make on validation. The thing is, there's lots of different types of consumers and producers, and we need to find a tasteful balance. All right, so if you're building, let's say, an indexer that uses something like Postgres, and you want to index data in some relational model, you would like to be very strict on validation, because that's how those databases work. Uh, but that is going to restrict a lot of people. It's going to restrict what types of things we can do, and it's going to break a lot of things. So then, okay,
Mhm.
we want to have like a looser kind of type system in a sense. Question how that's going to affect people. If you want to build a Postgres index, or whether the answer is you can't. You have to use a graph database. I don't know. So
Mhm.
there's interesting questions about validation, and if right now we want to impose any stricter rules and what the trade-offs are.
Mhm.
So those are a few interesting areas that we'd
Okay.
love discussion on.
Cool. Just to repeat back what you said for clarity, the spec feedback that you're looking for, representing IDs, native types, did we pick the right native types, adding parquet, validation, changing the attributes value type, what trade-offs are acceptable. Does that all sound
Yeah,
like a good
that's
little bucket?
perfect. Perfect
Okay,
recap.
all right. You hear it, devs. All right, get out there and get the feedback to Yaniv and all of the people working on this spec. With that being said, Yaniv, all questions from the chat have been asked, and of course, I'm sure there are many, many more questions I could ask right now. However, I think with this amount of information being shared right now, this is a great step in the right direction. The last question I'll ask is specifics, actually. It just came to mind. You said there's a short time period for the GRC-20 spec to be open before it's actually printed. Do you have a date on that closure of what that date is?
We do not have a date, but we would love any feedback in the next like week or two.
Okay.
So this is, we released this over a week ago, and so would love it if people could kind of make time and jump in. The sooner the better.
Okay, sooner the better. All right, devs, hear that out there. So, with anything, is there anything else you want to say before we head out and close this session of Graph Builder's office hours?
I think it was a really great coverage. So, I think at this stage, just getting familiar with the concepts is really great. And then, stay tuned for early next year is when we're going to be ready to really, release the framework, put the stuff in your hands so that you can integrate this into your own apps. And in the meantime, let's spread the word. Let's make sure people know about knowledge graphs, how amazing knowledge graphs are. We're going to be at the forefront of a really big revolution here, and excited to do that with all y'all.
Awesome, awesome. Thank you so much for your time, Yaniv, and everyone out there who's watching Graph Builder's office hours. Thank you so much for joining in. We'll be here next week, December 12th, next Thursday, for the next episode of Graph Builder's office hours. So take care, everyone. Have a good rest of your day, and thank you for your time.
Thanks, everyone.